Ever pondered the problems farmers face due to the towering height of modern corn plants? In the heartland, corn crop is a crucial part of the economy and the food supply. But the tall stature of these plants, often twice the height of a person, makes them vulnerable to snapping or tipping over in strong winds, causing significant losses. Take, for instance, the devastating windstorm in Iowa on August 10, 2020. It caused significant damage to corn and soybean crops, with losses estimated at a whopping $12 billion. However, a beacon of hope emerged amidst this destruction: experimental corn plants developed by Bayer, which showcased remarkable resistance to the storm due to their shorter stature. Now you might be wondering, how does the height of the corn plant affect its survival? Well, it's straightforward. Shorter corn plants increase wind resistance and allow farmers to maneuver their tractors into the fields later into the summer to add late-season fertilizer or fungicides. This not only mitigates the risk of crop damage, but also enhances yield, as short corn can be planted more densely. This innovation didn't occur overnight. It's the result of relentless efforts by plant scientists and seed companies who are developing these shorter corn varieties through both conventional breeding and genetic engineering. Bayer, a pioneer in this field, is currently concluding its final round of US trials and plans to start selling seed to US farmers next year. Other large seed companies like Corteva Agriscience are expected to follow suit with their own varieties soon. Historically, the development of short crops isn't new. Back in the 1950s and 60s, semi-dwarf varieties of rice and wheat were created, allowing plants to bear more grain without collapsing. This tradition of crop improvement continues today with corn. Corn, domesticated in southern Mexico about 9,000 years ago, has evolved over millennia of selective breeding to become one of the world's dominant food crops. But the tall stature of modern corn plants was a problem waiting to be solved. And that's where Bayer stepped in, using conventional breeding to create 3 short hybrid varieties that demonstrated better wind resistance compared to tall corn. To expedite this process, Bayer turned to genetic engineering, focusing on a plant growth hormone called gibberellin. By suppressing corn genes that code for enzymes known as gibberellin 20 oxidases, the levels of gibberellin can be lowered in the stalks, but not the flowers, stunting the plant's growth without undermining their productivity. After many trials and tribulations, they were able to create plants that were 1/3 shorter by adding DNA that encodes microRNAs. Field studies confirmed that this manipulation did not affect the ears of the corn. They weighed the same as those from typical tall varieties. This successful change in stature by interfering with gibberellin was the first of its kind in corn. In summary, the development of short corn plants holds great promise for farmers. Not only do these plants increase wind resistance, but they also offer the potential for higher yield due to denser planting. With the final trials concluding, the future of farming could very well see a shift from towering corn plants to their shorter, more resilient counterparts. And that, folks, is a big step forward in the evolution of corn farming.